Our research is predicting purchasing decisions of online shoppers using machine learning. And this research was done by myself, Isabella, Shahab, Dorian, T, and Philip for the class IE4305 under the professor Dr. Labullock.
As we are aware of, global e-commerce sales have been skyrocketing since COVID-19, with a total of $4.28 trillion in revenue. We think that if a business can predict whether a customer will make a purchase when visiting their website, then they can analyze the data collected from those customers to better allocate resources and advertisement. And that is our goal for this project. We conducted this research using Python and applied 6 machine learning algorithms. We then picked out the 3 best models, which were random forest, logistic regression, and SVM. The accuracy scores were 88%, 87%, and 87% respectively.
For experimental setup, I would like to start with our dataset description. The dataset included 18 features, including 17 predictors and 1 response variable, which was a Boolean, with a total of 12,330 samples. For pre-processing purposes, we applied 3 different methods to prepare the dataset for analysis, including encoding, scaling, and synthetic minority oversampling technique, SMOTE. As it can be seen in Figure 1, the training dataset was imbalanced, which could potentially introduce bias to the model predictions. So SMOTE was applied to the training dataset to add new samples and balance the dataset by adding an additional 6,359 samples.
For the experimental test plan, 6 models were tested and the 3 best were selected. They were selected for parameter tuning using the grid search CV parameter approach aiming to improve the F1. Figure 3 plots the accuracy versus the F1 score for each of the 24 preliminary modules. Our goal is to have a high accuracy and F1 scores, so the best models will be in the top right of the graph. And looking at these best models are random forest, SVM, and logistic regression. The first selected model, random forest, uses the outputs from several decision trees to make a prediction with its parameter to tune being the n estimators. The second selected model, SVM, is used to find a hyperplane, which is an n-dimensional space that distinctly classifies the data points with its parameter to tune being c. The third selected model, logistic regression, which is a predictive analysis algorithm based on probability and uses a complex cost function defined as the sigma function or the logistic function, its parameter to tune also being c.
The experimental results section shows model accuracy before and after grid search was applied. With the ROC curve, we can compare model performance across possible classification thresholds. The x-axis of the ROC curve is the false positive rate. Since the positive class in this dataset is revenue, the false positive rate is the rate at which the model predicts revenue, but no revenue occurs. The y-axis is the true positive rate, which is the rate at which the model predicts revenue when revenue actually occurs. By taking the area under the ROC curve, we see that the random forest model outperforms the others across possible classification thresholds. The confusion matrix of the random forest model shows true positive, false positive, true negative, and false negative outcomes, so we can evaluate the performance at a particular classification threshold.
This project looked at predicting online shoppers' behavior based on their browsing patterns during a website visit. We found that the 3 best preliminary models were random forest, support vector machine, or SVM, and logistic regression. And the best of these 3 was the random forest model, with, in the end, an accuracy of 88.8%, which means that we can predict with 88.8% accuracy whether an online shopper will make a purchase when they visit an e-commerce bookstore. For further research, we'd like to be able to predict with 90% accuracy whether they'll make a purchase when they visit a bookstore or not. And finally, for this research, we'd like to thank Dr. Labullock for her help.